For my final project, I will be discussing the physics of the game Red Dead Redemption 2 and the physics of baseball. So some concepts that I will be discussing today is the concept of free fall, the concept of forces, the concept of energy, power, and work, the concept of momentum and collision, the concept of rotational motion, more specifically torque and inertia, and then lastly I will be discussing the concept of projectile motion. So let's first discuss the physical concepts seen in the game Red Dead Redemption 2. The first concept is free fall. Free fall is when the force of gravity is being exerted on an object that is going in a vertical motion. Every object, regardless of its mass, falls at the same accelerated rate of negative 9.81 meters per second squared. This was proven by the famous Italian scientist Galileo, who discovered the relationship between the change in velocity and the distance of the two objects were the same, regardless of their mass. Gravity pulls down objects at the same constant rate. The reason why objects fall faster than others in real life is due to the air resistance being exerted on the object. So this is a video of free fall seen in Red Dead Redemption 2. So let's analyze the problem since we now know the concept. An arrow is fired up directly into the air with a velocity of 89 meters per second. What is the maximum height the arrow will reach? So we know the final velocity is 0 meters per second once it reaches its maximum height. Its initial velocity is 89 meters per second, and we know the force of gravity is negative 9.81 meters per second squared. We do not know the time, nor the maximum height, which is d. So we can use the equation final velocity squared equals initial velocity squared plus 2 times gravity times the distance, or the maximum height. We can rework that equation to turn it into d equals the final velocity squared minus the initial velocity squared divided by 2 times the force of gravity. When we plug in the answers, 0 squared minus 89 squared divided by 2 times negative 9.81, we'll get a maximum height that the arrow will reach, which is 403.72 meters. Concept number 2 is forces. Forces are always acting on an object, whether it is at rest or in motion. Forces cause the motion of an object and are measured in newtons, which is seen by the variable n. There are 4 main forces. The first one is the force of gravity, which is always being exerted on an object in a downward direction. The normal force is the contact force that is always perpendicular to the object's contact surface. The force of friction acts in opposition to an object's motion, and there are 2 main types of friction, static and kinetic. And lastly is the applied force, which can be a push or pull force which causes the object's movement and is applied by another person or object. And this is the concept of forces seen through Red Dead Redemption 2. So let's see the problem. A man is getting dragged by a lasso by a man on horseback. The man on horseback is pulling the man with an applied force of 50 newtons at an angle of 30 degrees above the horizontal axis on a dirt road with a coefficient of friction being 0.55. The man being pulled has a force of gravity of 60 newtons. What is the net force of the man being pulled? So, since we know the coefficient of friction is 0.55, we know the force of gravity is 60 newtons, and we know the force applied is 50 newtons at a 30-degree angle. So the first thing we need to do is find the normal force. And we can get the normal force by subtracting the force due to gravity by the applied force in the horizontal direction. But since the man is getting pulled at an angle of 30 degrees, we have to multiply 50 by the sine of the angle to get the horizontal applied force. So we subtract 60 minus the minus 50 sine of 30 to get 35 newtons, which is the normal force. So since we have the normal force, we have to get the force of friction, which we can find by multiplying the normal force times the coefficient of friction. And we can use the normal force we just got and multiply that by the coefficient of friction to get 19.25 newtons. And now to finally find the net force, we subtract the applied force minus that of the force of friction. So we plug in tangential functions again to get the horizontal applied force, and we subtract that by the force of friction we calculated, and we get a net force of 5.75 newtons. Next is the concept of energy, power, and work. Energy is the capacity to do work, and work and power cause an object to move via transfers in its energy. There are two main types of energy. Potential energy is stored, and then it is converted to kinetic energy when in motion. Work is energy transferred over a distance by an external force. Work is mainly measured in joules, which is seen by the variable J. Lastly is power, which is the rate at which energy is transferred, and is also the rate at which work is done. And it is measured in watts, which is seen by the variable W. We will be analyzing a duel now to check the power of the bullet. Okay, now it's time to solve the problem. A cowboy draws and fires his revolver at a target 10 meters away. The bullet fired from the revolver has a force exerted on it of 300 newtons, and it takes 5 seconds for the bullet to reach its target. What is the power of the bullet as it hits its target? So we know that work is equal to force times distance, and power is equal to work divided by time. So to get work, we multiply the force exerted on the bullet, which is 300 newtons, and we multiply it by the distance of 10 meters to get 3,000 joules of work done on the bullet. And now, since we have the work, we can plug it into the power equation and divide the 3,000 joules of work by the 5 seconds it takes for the bullet to reach its target to get a total power of 600 watts. Now it is time for baseball. And yes, all of these are my favorite teams. So, the fourth concept is momentum and collision. Momentum is best described as mass in motion. It is the relationship between mass and speed and has an effect on how the object moves and to its impact overall. The relationship between mass and velocity in momentum can be seen in the equation momentum equals mass times velocity. When two objects impact each other, it is called a collision. There are two main types of collisions, elastic and inelastic. During an elastic collision, kinetic energy is conserved and the two objects bounce off each other. In an inelastic collision, kinetic energy is not conserved and the two objects stick and move together. It is important to note that both collisions conserve momentum. So this is an example of momentum and collisions in baseball. So, problem number 4. A baseball player hits a 0.142 kilogram ball with a 1.02 kilogram bat exerting a force of 50 newtons. The ball takes about 3 seconds to hit the ground and land at its final position. What is the momentum of the ball, and was kinetic energy conserved when the ball hit the bat? So, to solve the first problem about what was the momentum of the ball, we know that momentum equals mass times velocity, force is equal to mass times acceleration, and final velocity is equal to an initial velocity plus acceleration times time. So, using the force equals mass times acceleration equation, we can change it around to find the acceleration of the ball by dividing the force by the mass of the baseball bat to get the acceleration, and the acceleration is equal to 49.02 meters per second squared. Since we know the acceleration, we can plug it into the equation final velocity equals initial velocity plus acceleration times time. The initial velocity is 0 plus that of the acceleration, which is 49.02, times that of the time, which is 3 seconds. We will get a velocity of 147.06 meters per second. Then we plug it into the momentum equation of the mass of the ball, which is 0.142, times that by the velocity of 147.06, which will get a momentum of 20.88 kilograms per meter per second. The second part of the question is the kinetic energy is conserved because the collision is an inelastic collision because the ball bounces off the bat. Concept 5, rotational motion, torque, and inertia. Inertia is the resistance of any rotational movement because of this, it can change an object's speed or direction of motion. The equation of inertia is inertia equals mass times radius squared. The larger the radius of an object, the more inertia it has, and the more inertia it has, the slower an object will go. The other quantity of rotational motion is torque, which causes an object to rotate about an axis. Torque has a direct relationship with angular acceleration, in which torque is proportional to. Torque is the quantity that causes angular acceleration, and the equation is torque equals force times radius. And here is a video of torque in baseball. So here's the problem. A pitcher throws a 0.142 kilogram baseball with a radius of 0.23 meters. The pitcher throws the ball with a force of 14 newtons. What is the inertia exerted on the ball, and what is the torque exerted on the ball? So we know that inertia is mass times radius squared, and torque is force times radius. So to find the torque, we multiply the force of 14 newtons times the radius of 0.23 to get 3.22 newtons per meter. And then to find the inertia, we multiply the mass, which is 0.142, times the radius of 0.23, and we square that to get the inertia of 0.01 kilograms meters squared. So the last concept is projectile motion. Projectile motion is a form of motion experienced by a launched object. While in the air, the projectile is only subjugated to the force of gravity being exerted on it at an accelerated rate of negative 9.81 meters per second squared, as discussed in Concept 1. While in projectile motion, the object is calculated in two axes, the horizontal and the vertical directions. Height is y, while distance is x. The equations for projectile motion are as follows. Distance is equal to initial distance plus velocity, initial velocity times time, and height is equal to initial height plus initial velocity times time minus 1/2 gravity times time squared. And here is projectile motion. Okay, now it's time for the last problem. A baseball is hit with a velocity of 44 meters per second at a height of 1 meter off the ground. How far from the batter does the ball land? So we know that height is 1/2 gravity times time squared, and distance is initial velocity times time. So we work the height equation, since we know the height that the ball is hit and the gravity of 9.81 for t equals square root of 2 times 1 meter divided by the gravity of 9.81 to get a time of 0.5 seconds. And then we plug that in with the initial velocity of 44 meters per second to get 22 meters or 72 feet. Thank you.